So yesterday with 5.1, we basically talked about simple probability, what it means, what a valid probability model or situation is, as well as some simple measures to calculate. So like if you were given a situation, you were just asked to find the probability of one event happening, or you were asked to find the probability of one event not happening. Okay. And then we talked also about the meaning of probability, that even like in the short run, if you were to do an experiment on, say, flipping a coin in the short run, like the probability of getting heads is a half, but in the short run, you wouldn't be getting a half. You'd be getting above it or below it. It's only after you do many, many, many trials does it approach the probability of one half. So, and that kind of answers one of the questions in the exercises. Probability is not predictable in the short run, but it is predictable in the long run. Okay. Okay. So what happens if we have situations that are a little bit more complex? Like if we're given situations and we're asked to find the probability that one event and another event happen, or the probability that one event or another event happens. These words are very important when dealing with probability and or. So the first thing I want to talk about is the notation and sort of a visual representation of showing probability of different situations, which we call unions and intersections. So what we do, and perhaps you've all seen this at some point in your academic career, these kind of overlapping circles called the Venn diagram. Okay, we can use Venn diagrams to sort of visually show probabilities of situations. Okay. So we're given some situation, we've got two probabilities going, we've got two events going on, A and B. So the probability of A would simply mean the probability event A occurs. And similarly, the probability of B would be the probability event B occurs. We talked about these things yesterday, how to calculate them, but to show them visually, if we had, say, two events, the probability of A occurring, we would just simply shade the entire circle of A. There could be some overlap with B happening, and that's okay. Because A could happen by itself, A could also happen with B. But we'll talk about that in a second. So the probability that B occurs, we would just simply shade the circle of B, including the overlap with A. What does the probability of A with the little c mean? Event A doesn't happen. So the probability event A doesn't occur. Well, to show that visually, we'd have to shade everything outside of circle A. So what we need to do in this case is we're going to put a rectangle around this one, because we need to shade everything outside of A. So there may be stuff going on outside of A and B. It would look like that. Basically, you would put in a rectangle to talk about the whole situation. And then you would just shade the rectangle outside of circle A. Now we've got some symbols, and we're combining events A and B. And there's different ways that we can combine them. When you see an upside down U, that is the symbol for the word and. So probability of A with this B would be the probability A and B occur. They both have to occur. How do you think you would show that visually? Yeah, just the section where they overlap. Because in this section here, this sort of three-quarter moon, only A is occurring. In this three-quarter moon, only B is occurring. In the overlap between them, both of them are occurring. The second symbol, a right side up U, means or. Big difference between the words and or. So this would represent the probability A or B occur. How would you show that visually? All of it. B may occur by itself, A may occur by itself, or they may occur together. All of those satisfy this sentence. And then this last one would be the probability of what? A or B don't occur. Or the probability neither occur. Well, that means we have to go outside both circles A and B. So we'll need a rectangle again, just to show the whole space. And then we just shade outside everything. Like so. So you need to be familiar with these words, because how we calculate probabilities in more complicated situations where there's more than one event depends on the wording. Depends on the wording. Okay, we may be doing some adding. We may have to do some other operations as well. So we're going to look at an example over the next couple of lessons that we're going to use sort of as a an example how to calculate all of these probabilities when we use addition and when we have to use other operations. And we're going to look at our dating website, OkCupid. Right? And we're going to specifically look at 36-year-old men, heterosexual, in the San Francisco area. Okay? So, let's say you're able to access, you're not able to access names and personal information, but you're able to access things, just a couple of things, okay? You're able to access their height, and you're able to access their income, okay? Chances are OkCupid would be publishing things like this, nobody else, because they wouldn't share this information, okay? So there's 192 men that are 36 years old, male, heterosexual, living in San Francisco. And we can put them into 4 categories according to how much they earn and how tall they are. So we have a short low earner, which means they're shorter than the median and the average income is lower than the median. All right, all right. We have a tall low earner. They're taller than the median, okay, but still average income lower than the median. Then we have a short high earner, right? I love how you all are judging right now as I say them. And then we have a tall high earner. Yeah, everybody's nodding now, going, yeah. Okay. So in this data, here are the numbers for each of the categories. So out of the 192, 21 are short low, 22 are tall low, 48 are short high, and 101 are tall high. I guess that's pretty good pickings. Okay. First of all, we have to check to see if this is a valid probability model. Is this a question that we can analyze? Okay, and remember the 2 cases. Do you remember them? All probabilities add to 1. Yes. They have to be in between 0 and 1. All probabilities add to 1, which means if you added all these fractions or all these decimals, you would get 1. And all probabilities, if you look at the fraction or decimal, the way they're expressed, they are all between 0 and 1. So that means it's valid. Because if it's not valid, we can't do these questions. Okay, okay, so yesterday we did a question like the first one, where we were given a table and we were asked to find, okay, in this case, what's the probability that you would select if you put all these, if you assigned each of these guys a number and you put them all in a hat, that you would select someone who's tall? Not a tall low earner, not a tall high earner, but just tall. How many are tall? Right. These guys are tall, and so are these guys. So the probability of tall would be 22 plus 101 over 192, which is 123 over 192. You can leave that as a fraction. You can change it to decimal. You'd have to round it likely. Okay, and usually when you round, go to 3 decimal places. And remember, if it's a fraction, you don't have to reduce it. Okay. Okay, now we're getting into the ones we just looked at on the previous page. How do I read the second notation? Tall and a high earner. 101 out of 192. And the third one is tall or a high earner. They could be one of the 2 or both. So it would be these guys, because they're tall. These guys, because they're high earners. And these guys, you're right. So what does that work out to? 171 over 192. Good. So something to remember from this is when we see the U, which means or, that implies that we're going to be adding probabilities. Okay? And remember that U just stands for union. And what does a union do? It brings together people. Whereas if it's ands, so we just look for a specific spot in our information. Okay. Besides a Venn diagram, which we'll look at in a second, if we have a Venn diagram of a situation because we have overlap between two events, we can put it in a two-way table. This is actually what we did in Unit 1. Okay, and we did some calculations from the table. So it's very similar to what we did. Instead of now, in Unit 1, I was asking you what proportion were this, or what percent were this. Now we're just saying, what's the probability of selecting this? It's still the same. It's the same answer. Okay? So we've got T and H again. So we can use the table to find the probability of a high earner. Where would you get your numbers from the table? What's the probability of selecting a high earner? How many high earners are there? Look at the table. 149. So we would go here out of the total 192. So the probability of selecting a high earner, there's 149 of them out of 192 total. This next one. So we got to make sure we read this correctly. The probability of selecting tall and not a high earner, right? So tall and not a high earner. Well, if they're not a high earner, they must be a low earner. So really, this is the same as saying tall This is the same as saying tall and a low earner. So this is where we got to go to this section of the table. Where do we see tall and low earner? 22 out of the total. It would be on the outside. Yes. Okay, this one, we see the U, so we're going to be added. What's the probability that we get tall or a high earner? There's actually two ways to do this. So one way to do this would be to say, okay, if they're tall or high earner, go to these spots where it satisfies one of them. So tall, high earner, high earner. So we could do 22 plus 48 plus 101 over 192 gives us, what was that again? 171. What's that? You okay? Okay. Another way we could do this, okay, and this is where the formula for the addition rule for probability comes in, is we could say, okay, there are 123 tall, right? Total. How many are high earners? 149. But didn't I count this twice? So I need to subtract the double counting. If you do it like that, you're still going to get the same answer. And that actually leads us to this formula. Okay? To find the probability of one event or another event happening, you find the probability of the first, you add the probability of the second, but you take away the probability that they happen together. Because when you add two together, you're always double counting the overlap. So you got to take away one of those overlaps. So this is important. And I believe you would get that formula. No, maybe not. I'd have to double check the formula sheet. Anyway, so this portion or means add. So that's why we add PA plus PB. Okay. But then we have to subtract the double counting. So knowing this formula can answer, I don't have to give you all this information. I could say the probability of something happening is 1/5. The probability of something else happening is 1/6. The probability of them both happening is 1/3. And then you would be able to calculate the probability of one or the other using this formula. Okay. Not only can we show it using a two-way table, we can also convert a two-way table to a Venn diagram. So notice how it's done. Okay. Notice when we go from a two-way table to a Venn diagram, these are the values we put in the Venn diagram. We don't put the totals in. Okay. Because if you look at it, okay, remember T means tall, H means high earner. Short low earners don't go in either of those circles, which is why it goes outside. Tall low earner, okay, it means that they're tall, but they're not a high earner. So they go in the tall circle, but they have to stay outside the high earner circle, which is why they go here. 48, similarly, they're a high earner, but they're short. So they go in the H circle for high earner, but they have to stay outside the tall because they're short. And then we have the ones that are both that we put in the overlap. So again, we can answer questions from here. So using either the table or the Venn diagram, what's the probability of selecting a high earner? 149 over 192. Here, the table, you would just do this over this. Here, if you were only given the Venn diagram, you'd have to do all the ones that are in H over all the ones all together. Okay? You may be just given one or the other. You've got to be able to calculate probabilities from both. How about the second one? Sorry? 101, because it's both of them. So it's either going to be this cell in the table over the total, or if we look at the Venn diagram, the overlap value. High earner and, well, if they're not tall, short. So high earner and short. So we can either go to the table and see 48, Or we can go to the Venn diagram and say, okay, we want a high earner, but it's got to stay outside the tall circle. So 48 again, over 192. Not a high earner. How much, sorry? 43? Yeah, so it's probably best to get it from the table here. If they're not a high earner, they're a low earner. There's a total of 43, doesn't matter whether they're tall or short, out of the 192. So that's from the table. If we were to do it from the Venn diagram, we would have to say, okay, everything outside the high earner circle. So 22 plus 21, which gives, it has to give us the same answer. But again, you should be familiar with how to do both, because in a situation, you're not going to be given both. You're going to be given one of them. Okay, so you've got to be able to know how to read a two-way table to answer these and read a Venn diagram. And finally, tall or high earner. Well, we can go to the table. Like if we go to the two-way, we've already done this question before. So they can be tall or they can be a high earner. So it could be 22, 48, or 101. Out of 192 of them, which gives us 171 out of 192. How would you calculate it if you didn't have that table, you just had a Venn diagram? There's a couple ways you could calculate it. Thinking of the probability formula. Everything on the inside and add it. Yeah, that'll do it. Because it would be, here's the ones that are just tall. Here's the ones that are just high earners. Here's the one that are both. Or we could add the two and subtract the overlap. Just to add all the talls together. Like if we added all these together, but remember when I did that, I double counted the 101, so I have to take it away. You do have to be familiar with how to do that. But again, we could just do 22 plus 101 plus 48. And again, we get 171 over 192. Okay. The last thing that I just want to talk about very, very quickly, what happens if there's no overlap? Okay. What happens if the events have nothing in common? Well, we give that a special name. We call them mutually exclusive events. And this is what mutually exclusive would look like in a Venn diagram. There's no overlap, so the circles are separate. Okay. So they have no overlap or intersection. In other words, they both cannot occur, or they cannot both occur. So there's all sorts of examples of that in probability. I mean, I could just simply say, like I believe I talked about this one yesterday, if you flip a coin, what's the probability of getting heads and tails? 0, because it's impossible. Okay. What's the probability of getting heads or tails? 1. So to find the probability of mutually exclusive events, we don't have to subtract any overlap because there is none. So that's why it's just like this. So you don't have to worry about the overlap. or subtracting away the double counting. Okay. You might find this of interest. Do you believe that many of the men on OkCupid are lying on their profiles? Okay. And here's some data. Here's the percent growth in male median wage from the time they're 22 to the time that they're 60. Here's the actual percent growth. Okay. Here's the growth on OkCupid. Significantly higher. So that suggests that they're saying that their wages are much higher than they actually are. Okay. And they, who knows, we could probably get similar results if we did, if we looked at their heights too, over a period of time. Okay,